Hi, welcome to the second part of our helpers refactor, well, text model refactor, where we are at present trying to deal with the helpers. So in the first part we did a quick copy and paste job to get the helper interface copied across, plus a couple of other classes, and so we got the gist of the functionality needed to support helpers. So this is the tidied up interface that's going to abstract the individual interfaces that we've got in the technical space specific models. So here we have the helper transform for the C++ technical space, and here we have the C# one. So what we're going to do now, which sadly is going to break a lot of stuff, is we're going to try to delete the existing interfaces and replace them with a new interface, and then update the existing transform. And when I say transform, I really mean the whale templates, to rely on a method that we have got in the base class for is enabled. Here we are. And hopefully, I mean, this is going to cause a lot of breakage really, but hopefully we should, by the end of this, end up with a single helper interface. I mean, we still will rely on the helper transforms, so the context, we still will rely on the context, and we will still rely on the existing repository and registration for the helper transforms. So that won't change. And we will still rely on the assistance. But what we just want to achieve is to move over to this single interface. In theory, you could do just C++ first and then C#, so that at least that limits the scope of the chaos and havoc. Still going to be pretty bad. I think we haven't started the clock. So we probably have done 5 minutes perhaps, so 42. Yeah, I think that should do the trick, I think. So okay, let's just get cracking then. So I'll just remove this guy here. Now of course I don't necessarily need to delete the transform itself, but it's just easy if I delete it, because all the references now are going to fail to compile. In an ideal world we just do the deletion in the second step, but it just makes life slightly easier to locate the breakage. So if I just generate everything, let's make sure we got a latest code generator. We do. Now if I just generate everything. Right, so now we're going to start to see the breaks. So first break is probably the context. Now I'm not sure if this is gonna take us there, because no, it does. Okay. Right, now let's try to get this to compile. That's going to be a lot of breaks, but so the very first problem we're going to have is the, oh, interesting. Oh, did we delete C# into the C++? We did, okay. So let's just revert that change, start again. To be fair, we probably should have started with C# because it's smaller, but we always start with C++, so. So let's try again. Let's move to an English keyboard as well. Also, let's just. Right, so there's two of these guys. Probably the repository suspect. Right, so what we'll do is we'll just make sure that all of this is captured here, and now we can start to attempt to compile. Now the very first problem is going to be very obvious. It's Oh, it's actually saying handcrafted code. I suspect it is. So okay, so we can fix this quite easily. So all we need to say is something like this guy now becomes text dot transforms helper transform. Something like this. So if I just do a quick search for helpers. Okay, so while we're here, not quite what we meant to say. Well, to be fair, let's just have a look at what this guy's saying. Interesting. The LSP is just a little bit upset at the moment. We're just going to ignore LSP for a second, because I think these errors are not reflecting the real error. So however, okay, let's just have a quick look at our LSP area to try to understand the errors we're getting here. Seems as if LSP is not updating. So let's just do revert buffer, I guess. Actually, a revert buffer, interestingly enough, does not seem to reset LSP, funnily enough. Okay, right, that's it. So let's just follow the path. Here we are. So the problem is actually quite straightforward. Keep making this mistake, but there we are. So that's that guy. As you can see here, there's nothing particularly creative. We are just going to make sure the context is referring to the new transform we created. Nothing special. Right, now that we've done that, let's just resume our attack on the repository and see. Okay, let's look better at the breaks. So at some point we're going to break in the transforms themselves. So this is the registrar. I thought we did the registrar a second ago, but clearly not. Not sure, but sadly this is going to be the type of problems you're going to face for a little bit. Okay, so presumably this is actually the old legacy registrar, which we need to update just for now. index.cpp registrar. Similarly here. A few of these. Okay, so hopefully this will solve the registrar issues. Now we just need to refer to the right I/O, and I suspect a couple of problems here. Right, so simulating assistant. We're also going to have a few of these guys. So none of these things are going to be particularly complicated. It's just sort of usual search and replace, I guess. Which also makes me wonder if this is the right sort of material for a video, because I think it might be a bit boring. But anyway, we're trying to show you a sort of a realistic portrait. So right, so now here we are. First problem. Here we need. So first thing we're going to need is something like context.model, not the physical model. Followed by an entity. It could be elements. Followed by an artifact. I wonder if we have an artifact? No. Oh, we do have an artifact. I don't know why it didn't come up, but I didn't put a comma here. And followed by the element properties. So that should now give us all we need. And then to apply, I assume it's going to be something very similar. So you can see we haven't done anything very clever here. So apply has an outward stream, so presumably we could just say something like, well, let's see, stream. So you see, we just very carefully are trying to just convert this code to a slightly more sensible way of doing things. Now, what we have here now is going to be all of the transforms. We tried not to do C++ and C# at the same time. This might be possible. It might be possible. Let's have a quick look at how these transforms get generated. So, if I just jump over to the legacy dependencies transform, this is the hack that we've got at present that obtains per transform. And as you can see here, we've already prepared it for a day where we would have the include coming from here. So if I then just cleverly replace this with this is now going to generate the right code. But of course, you must remember we're in the middle of a very large change. So the best thing to do is to say, please in fact, to be honest, let's think about this for a second. We need a code generator with this change. I suspect when we attempt to apply this, we're going to have a problem. So what we'll do is, let's just unstage everything. Then let's just look at the non-deletions we have here. So I'm just going to take everything which is not a deletion. And then I'm going to do a ZI and say, I don't know, compilation fixes perhaps. Then I'm going to take the deletions and say something like deletions maybe. And finally, I'm going to generate the code generator with just that one change. It's going to take a while to build because we touched a lot of files while we're faffing around here. And this is going to redirect all the headers pointing to the new interface. In general, I think what you're seeing here in Dogen is an example of a sort of very incremental way of doing changes to code. You probably wouldn't do it quite like this in a professional environment. You would do it slightly quicker instead of worrying so much about the intermediate steps. But you must remember that when you're doing this kind of work, we never quite know when you're going to get a chance again to work on something. So if we start a massive refactoring that involves maybe, I don't know, 2 or 3 days until we get things to compile, the 2 or 3 days could be a week, 2 weeks, 3 weeks worth of development. And because you keep stopping and starting, we will most likely forget about what we're doing. So that's why we developed this technique of highly incremental changes, especially in these really long refactorings, which we'd probably not do if we're doing this on a sort of a daily job. In a daily job, you would probably just go in and, you know, embark on the very large refactor and have one big fat commit. But that's just not suitable for this kind of development, really. Right, so what we're going to do now is we're going to co-generate this. Now what we'll see is that all of our helpers will now move. And then we're going to not commit, we're going to stage all of this. And now, because the deletions are already here, we're not going to worry about the deletions, we're going to take everything else. Right, so my Git still thinks we're going to clash. I'm not entirely sure why. I think most of the things went in, as you can see here. It's probably just going to be a couple of changes. I'm going to ignore this error. I think most of the stuff unstashed. I think just a couple of files probably didn't. So we'll just unstash and see what we get. Okay, cool. Right now, second problem. The second problem is we need to refer to the right transform. Now what I'm going to do is I'm going to do two things here. I could do the same thing we just did and update the transforms to regenerate the code, but that's going to take a while. The easiest thing to do is to say, for now, let's just I don't think we have RG open, do we? Right, let's open up a new area. So let's just do something. Let's just grep, in fact not even RG, for something that looks a bit like this, recursively. That should give us the vast majority . Indeed, this gives us the vast majority of the stuff we need. So what we'll do is we'll grep here. We just have to be careful not to take the C# changes here. It's only a couple, so it's not a problem. So if we just go over to wool grep and say something like, please change these guys to now be text transforms helper transform, and that will just take over all of these guys. Now we don't want the C# one, so we will really carefully just undo these guys here. And then we'll save. Now, of course you would say, but you haven't changed the template, so next time you run the code generator, this is going to break. And that is correct. So what we do need to do is we very carefully need to just jump over to the C++ model, find the header template for the helper, which we introduced recently, extract the contents, and then just make our change here. Now the reason why I'm doing this way is just to avoid having to rebuild the code generator and stash, you know, the usual. So that deals with that issue. We just have to keep in mind that we are not running with the latest code generator, that's all. Okay, so now what we get then? Aha, we have another problem here, which is we're not including the assistant directly in the helper file, so seems we can't get away from regenerating the code generator because, well, to be fair, I mean this is a bit more painful, but let's just have a quick look at our grep again. So if I just grep for text transforms, and what we'll do is we'll just have a quick look. I mean, there's absolutely nothing we can do here. We have to include Dogen.text types transforms. Although having said that, there is something that's not quite right here. Yes, we just made a mistake. We shouldn't really be relying on the assistant anymore. So that is correct. So what's happening at the moment is the interface is incorrect. So the interface now should match the new interface. And again, we won't be able to do this via the text transform because it would just take us too long. So the easiest way to do is to hack it. So let's just see what happens if I just quickly hack this. So we need a few things here. We need an override. I do not think we need the virtual anymore because no one is going to inherit from us, so just adds noise. So I think I'm just going to actually try to do this manually, I think. Let's just update the template as well. I mean, clearly the right thing to do would have been to update the template and then to regenerate the code, but in order to do that I need to have a fairly clean sort of set of stashes and unstashes, and that's just going to be another whole series of issues. So what we'll do instead is we will just use that grep and quite possibly create a macro, I think it's pretty right. So if I just create a macro here, so we find the next, we go down, we delete, and we paste, we save, and we close the macro. So I think this probably will apply quite cleanly. Okay, so that's fine, the macro is working. We just have to go through these, not the fastest, but still quicker than redoing the code generation. You can follow the progress over here as we go down. Oh, I think I made a mistake here. Right, so what I meant to do was Control X, E. So now we're going to go through these 30 or so assistants. It's just the headers, of course. If you're a really clever Emacs user, you would actually just create a macro in such a way that you would select these lines here and then just say, oh, this seems to happen a few times. I think if you wiggle with the mouse, it seems to get a bit out of whack. So if you're a clever Emacs user, you would just do the apply macro to region lines, and instead of having to press E hundreds of times. But then you'd have to make sure that you make the macro starting from the set of lines. It's not that complicated really, but I'm a bit of a lazy Emacs user, I guess. I must say that Emacs is one of those sort of editors that if you want to use Emacs or VI for that matter, you should really spend the time trying to learn how to use the editor, because if you're going to use Emacs like if it was sort of a Visual Studio or a glorified Notepad, it really is not that kind of editor. It's going to take you a lot longer to do things, and you're not going to really benefit very much from Emacs. It's almost like you have all the disadvantages of Emacs and none of the advantages. So if you really want to use Emacs, you have to make the effort to read. Now that was a bit of a mistake. So let's just do an undo here. Yeah, as I was saying, you should really make the effort to read through and learn how Emacs works, because it's pretty pointless really to have all this raw power to just use it for the basic stuff. It does require time, sadly. Right, okay, so now we're getting into the implementations. So what we're going to do is, for the ease enabled, so we've already updated the template for the header file. We need to do the same for the CPP. Let's just have a quick look at the first of these guys. I suspect these are going to be quite straightforward. So on the simple case, probably just needs the ease enabled signature, I think. And then we just need to say, well, I mean, clearly you should just have a base function that implements the simple case, but as I say, let's not get too lost here. This is just to get us going. Right, so that is just going to return true. Let's make sure this compiles. Well, not compiles, but at least goes past this error. Doesn't seem to. Probably missing the bracket. Right, that solves the first problem. Now let's solve the second. Second problem. The problem is we are using the assistant. So what we need to do here is to say please supply me with a stream and then as required. I'm not really sure why we need so much stuff on the apply. But at any rate, that's what he's saying, so let's just go with it. So we need something like this. And this is all generated code, so we need to be very careful to make changes that are not going to break the world. Now, as you can see, we don't seem to be asking for anything from the element. Anything for the artifact, which means we probably should sorry, I hear some noises. Okay, it seems like we paused our recording for a fair bit. I thought we were recording, but we weren't, nevertheless. So while we paused the video, we did quite a few changes here. We thought that we didn't really need the model in the interface, but it seems we do. And we made a mistake, well, it's related to the first statement, but we made a mistake assuming that the assistant was being used only for the stream. It seems that we are using other things in the assistant, some of which are not trivial. So one of them is quite trivial, we're just creating a scope namespace. We could just simply add that, but this chap here is doing some kind of lookup in the model. So we need to go back and implement this on the base type somehow. So I think we're going to have to sort of stash all the changes at the moment, I suspect. Implement these two methods and then resume. I think that's probably the best thing to do. But however, when we do resume, we have to go back. I mean, there was a bit here where I thought I was recording, but it was actually on pause. But we just removed the model from the interface that we had added originally. And that actually was a mistake, because we need the model in order to do the streaming for type. So there's not a lot we can do here. So let's just get cracking with this, I guess. Oh. If we go back to the first, in fact, to be honest, while we're here, let's just think about this for a second. Since we're gonna have to undo our changes, we did so while we were not recording but thinking we were recording. I was describing that sometimes it is easier to change the code, to generate the code manually, rather than change the code generator to regenerate the code. The reason being that if your change is very complicated and it requires quite a lot of bits of the code generator, like for example, we have got a lot of stuff now our change here, and it's difficult to unpick the code generator changes from the actual changes we're trying to make. And sometimes when you get yourself into these sort of scenarios, it's actually easier to just force the changes manually and then update the templates and then double check that the templates are generating the code that you changed manually. And that is actually a technique that's used a lot in code generation. It's just simpler to do that because we are using the code generator to generate the code generator, and in order to do the changes you have to validate those changes. So sometimes you get the code generator into a state where it doesn't compile anymore, and then you're in a bit of a tangle. So the best way out of that tangle normally is just to search and replace and just do the changes. And that's one of the reasons why, if you look at sort of the code generator at present, we added a number of text templates, but we stopped adding more functionality at one point. And the reason why is we decided that we had enough to as a sample, we had enough to demonstrate the principle of the code generator. We didn't want more of these, because every time we get into these situations, you just add more overhead. And for our empirical approach, the sample size is already sufficient to demonstrate the empirical approach. So the further additions that are required for a practical sort of product are not really required to prove a point from a research perspective. So that's why we stopped adding any more functionality here, just so we don't have to carry the weight of additional templates and so on. So to recap where we're at, then we need somehow to fix these methods here that are the helpers are relying on the assistant. So what we'll do is we just grab these guys. Let's just put this in our log. And to be honest, we did actually put this in our analysis. We just forgot about it, I think. As you can see here, that's one and that's the other guy. So so that's good news, I guess, because we did do the analysis, we just forgot about the analysis. So we need to implement these two methods on the base type. To be fair, I'm actually going to risk it and just implement it in the base type quickly, because I reckon this is actually quite an easy thing to do. So let's just find the base type then. Helper transform. We have about 1 million of these things open. Let's text. Okay, there we are. So I think what we need to do is we just need to say, and I'll protect it a bit. In fact, to be honest, the best thing might even be just have the assistant here, because this is going to be copied from the assistant. So let's just say we have a make scoped formatter, scope namespace formatter. So let's say we have one of these guys here, and let's say we also have streaming for type. They're slowing down a little bit at the moment. Right, so this is our model. Seems like LSP is also grinding to a halt, like our brain is at the moment. So we'll just take this guy here. Looks like LSP is not copying very well with the hundreds of files we have open at the moment. So that solves that problem, and now we just need the streaming for type. Not quite sure why this is erroring, but yeah, there's about 10 of them. So right, as you can see here, we probably need a couple of these. So let's just grab these guys. Sadly, Max is really grinding to a halt at the moment. I think we might just need to close some buffers because LSP is really not liking it. Seems like treemax follow is part of the problem. Let's just see if I do a treemax follow disable. Does that improve things? Yeah, this seems to improve things. I think treemax follow is in a bit of a state at the moment. So okay, so the idea here is very simple. We copy across some functionality from the assistant in order to break our cycle. Notice that we copied the wrong thing. We really meant this guy. Still a bit slow. Okay. Not quite sure what's going on at the moment with Emacs. We see, well, I think Refactor follow is back again. Might be buffer local, I suspect. Okay, hopefully the follow now will disable. Though it seems to still be following. No idea why, but there you are. Right, this is all quite distracting. So what are we trying to do then? So we oh yeah, so now the problem is let's just try an LSP restart because the server is grinding to a really grinding. Never understood the difference between these two, but let's try the one with the shortcuts. Oh, okay. Clearly not. Wrong command. Right, so we need restart workspace. That one. Okay. I wonder if the LSP server just got itself into a bit of a state because it's been running for a couple of weeks probably. Sometimes these processes get quite large. I think I suspect our Emacs is needing some rest. Now the LSP or Emacs, let's see how long we've been running this Emacs. Yeah, 9 days. I find that Emacs with LSP sometimes it's not quite as stable as it used to be. It works okay, but if you use it in anger quite a lot, I mean, for example, at the moment we've got 200 buffers, not a lot really, but because they're all with changes and stuff, I think it's causing LSP to get a little bit upset. But seems to be responsive enough, so let's keep going. So what we're going to try here, with varying levels of support of LSP, I'm not quite sure what we got at the moment, but let's keep going. In a way, this is probably a good thing that we don't have LSP at the moment, because we'd have a lot of errors. So, let's just look for all of these. So make scoped namespace. Right, no, we're gonna have to pray that we don't really have anything here that is gonna require more functionality. Because we are sort of hoping so we need some utility formatters. Yeah, we're sort of hoping that the assistant, the bits of the assistant that the helper needs is quite self-contained. So here we seem to use utility formatter. I suspect. Right, so streaming for type, the first streaming for type seems to already okay, this is interesting. So I think we might even not require the model at all. Because, as you can see here, we are relying on, well, not even sure if we need two methods for this, but there you are. We seem to be relying on streaming properties that are already within the helper. So I think we're just gonna go with this. Now then, let's go back to where we were, and let's then say something like this. Let's say, just call your base type. Something like this, right? So this is now calling the protected method. And let's just for a laugh see what that does. Interesting. One tiny little problem here. We need to supply the stream. This is sort of a tightrope that we are going through here, because at any point we now find some massive dependency between the the assistant and the helper, suddenly it's all going to yes, there we are, and this is the sort of thing I was worried about. So let's have a look at what this is. And we now suddenly need to know whether we need standard right, so yeah, we're going to need the model, and I'm not even sure what model that requires, so that probably would be the logical model, I guess. Or is it the physical model? Interesting. So what exactly is this thing using to determine the standard? Technical space version. Okay, cool. So we just need to know the technical space version, which means the chain will need the technical space version. Now, I'm not quite sure where that's being obtained from. Let's have a look at where the context is created. Perhaps here. So that's the original context. And we go to the the logical space to obtain the technical space version. So, apologies. So not quite clear what we should do here, right? I mean, up to now we have one problem. It's not the biggest problem in the world. We could supply the technical space version to the transform. Don't need a whole logical model for that. And that is of course available at present, so could actually just do that, I think. So we could say something like this: specification entities, technical space version. This is on the apply. Then we would have to change every single apply. In fact, let's just have a quick look at this implementation, because it could just be. So we need to determine whether the scope namespace formatter is using In fact, no, I'm going to change my mind slightly. So the problem we have is that we are going to be calling scope namespace formatter. We need to know what kind of namespaces are we going to build, and that's actually relative to the technical space. And interestingly enough as well, you can already see a problem here. We are hard coding the technical space to be C++, which is not necessarily the case. So we have two problems really. We don't know the technical space version, and we don't know what is technical space really. And which reminds us again of that modeling error that we did, where we have something that's really not ideal. A technical space version implies technical space. So you can clearly see how we can easily make an invalid state here by choosing something like C# and then the version being something like a C++ version. So that's really not ideal. But that's not something to deal with right now. We just need to find a way to supply these two parameters to the transformer, to the helper transform. So we could change the interface, and I think that's really the only thing we can do. I think there's some noise coming from downstairs. Right, yet another pause in this video. It's becoming like the video of all pauses. We were struggling a little bit with the fact that in order to do the namespace formatter, we need to know the version of the technical space. This is all really, it's quite annoying because none of these things are real issues, because this is all kind of like the previous understanding we had of the world. None of it makes any sense anymore. This is code that we need to remove. We just need to move it forwards. And let's make sure we are recording. Yeah. And so we just need some kind of way. It can't be too hacky because we still have to maintain this code for a few sprints, so it can't be completely crazy. But it has to, just has to kind of get us over the line. Now the fundamental problem we have at the moment is this. We are going to call the apply method. The apply method has to supply us with enough information in order to call make scope namespace formatter. When we had the assistant, we had access to the logical model, which allowed us to know which technical space we're targeting in the version of technical space. We don't have that anymore, so we need those two bits of information. Since our analysis is telling us that these are the last methods that we're going to be using for the assistant, part of me just says, oh well, let's just supply these two bits of information then. So we're going to say technical space and technical space version are supplied, and everyone implementing this interface has to supply these two bits of information. And then we will say that if you are trying to create a scoped namespace formatter, you need to supply them as well. And I think, hopefully, this will take us over the line, I think. And now we could say, please give us technical space. And where we ask for this guy, we could say something like the technical space version must be equals to identification entities. Technical space version, presumably C++ 17. And that then solves the two problems, I think. It's not brilliant, and it's going to cause us a lot of pain, because we now have to go through all the code that we changed, some of which where we were paused and we weren't recording. And we need to make sure that these two bits of information are then supplied on the apply method of the helper. But there is no other option, so let's just get on with it, I think. So if we go back to the beginning of our graph, you'll see there's a lot of these guys here. They all need this. Okay, I think we can probably create a macro for this. So just put down, delete, jump over there. No, actually, it's a mistake. Let's just close this macro. Okay, this should have compiled. Let's just double check that we didn't break something. Ah, okay, we did. Not really sure where we did, but I think it's just not updating. It would be nice if our LSP decided to kick into action, but I think it really is not happy. I'm gonna try to see if I can get Emacs. Oh, LSP is convinced that there is a problem here somewhere. Not entirely sure what it is, but I think there's some kind of mistake here. Let's have a look at what we're doing. So first thing is, actually let's just do a direct jump here, because I think we are not working from the latest version of this. So well, okay, better. So at least now we're getting the errors. Now what we'll do is just go for a couple of includes to be on the safe side. If I just say something like types.entities.technical space and then the version, hopefully this would. Right, so now this is no longer a problem. See what's happening with the domain type helper. Okay, so now we know for sure this is the right thing to do. So now we can go back to our grep and we could say open macro. Ah, it's still on file check errors for some reason instead of grep. Okay, so it's now looking at grep, so we can do the first save, create a macro, and the macro is going to be next, down a few times, close macro. So right, this is being rather painful. Must say I'm a bit tired as well. The problem with this kind of work is that some of it actually requires quite a lot of concentration, but after the end of a long week doing other things that require concentration, such as work, it's not exactly easy. Right now we're gonna have presumably a whole lot of problems because all of the helpers presumably. No, okay, this is not a big problem. I think we can skip this guy. Let's just return to our compilation then. string. And we don't have a logger. Well, I'm going to make my life slightly easier by saying forget about the logger for now. Ah, bingo. Streaming properties are coming up now. I knew the streaming properties were required. I don't know how we did not get it there. So, right, this is a bit more complicated than we anticipated. We are pulling in a lot of the assistants. We thought on our first analysis that we'd be able to do this with a minimal amount of stuff coming in for the assistants, but I think we need to have a bit of a break here. This can't be the right solution because we're going to end up duplicating the entirety of the assistant in the helper, which, to be fair, might be the right thing to do. I mean, had we supplied the model, the logical model, we would have had both the technical space and the technical space version, as well as the streaming properties we need here. So perhaps that's what we need to do, really. We just need to go and modify yet again those helper methods, I think. Okay, well, I think we're just going to need a bit of a break here, I'm afraid. This is very slow going, not the particularly brilliant day in terms of coding, I'm afraid, but that's exactly the reality of coding, I'm afraid. So sometimes things just don't go your way. So let's just try to recap what we've done here and why things are going so badly. What we're trying to do at the moment is we're trying to decouple the notion of a helper with the notion of an assistant. Both of these things are very, very badly modeled, and they really, now we understand what these things should be. They are not really supposed to be there. So the notion of a helper is in effect a disguised platform definition model that we never understood correctly. But unfortunately, to actually implement the platform definition models, we need to do a lot of thinking. We need to do that properly. And we don't really want to block the entirety of the refactor of the existing code on the back of the PDMs. We do have PDMs in our plan, and as you can see here, PDM generation, we're not far from it, but we don't want to tackle the PDMs just yet because we're here at the moment, and if we start mixing too much of the PDM work with this stuff, we're going to end up not actually getting anywhere. That's the lesson we learned last sprint. So what we're trying to do is we're trying to say, okay, how do we decouple the PDMs from the work we're trying to do at the moment, or the helpers? And we can't move anything at the moment because in order to move anything, we need to move everything because the assistant is coupled to the helper, which then means that all the helpers are coupled to all the model-to-text transforms, which is a really big problem because that means that I can't just take a model-to-text transform and move it across to this model, because in order to do that, I need to have the assistant. In order to have the assistant, I need to have the helpers. And I can't take the assistant without the helpers, and I can't take the helpers without the assistant. So this is all jumbled up. So there's lots and lots of programming errors here, really, to do with the evolution of how these things came to be. So the right thing to do here is to try to decouple the helpers from the assistants, and then to bring in the helpers first, so that we can do this in a small number of commits, of self-contained commits. However, when we try to do this decoupling, what we're learning is that there is actually quite a lot of coupling between the two. And so we are more or less duplicating the assistant into the base class of the helpers, which is not necessarily a bad thing, but I'm wondering if we're doing that just because we're tired and we're not actually focusing, or whether that's actually really what's the solution to this problem. So points like this is always worthwhile to have a bit of a break, try to refresh your brain, and then come back with a fresher look at things, which is what we're going to do. Right, thanks for watching.